Assalamualaikum warahmatullahi wabarakatuh. I'm Aliya Sakandal, and today I will be discussing about standard normal distribution and normal distribution table from chapter 3, lesson 4. So for the learning outcomes on this topic, we'll be able to identify the regions under the normal curve corresponding to different standard normal values, convert a normal random variable to standard normal values and vice versa. Use the normal distribution table to get the area under the normal curve for a given interval. The definition of the standard normal distribution, also called the z-distribution, is a special normal distribution where the mean is 0 and the standard deviation is 1. A table showing the area under the normal curve from the mean to any standard score. Normal distribution table is a compilation of areas from the standard normal distribution, more commonly known as a bell curve, which provides the area of the region located under the bell curve and to the left of a given z-score, to represent probabilities of occurrence in a given population. This is the formula to convert raw scores to standard scores. Z is equal to x minus mu all over lowercase sigma, where the z is the standard score, mu is the population mean, x is the raw score, the lowercase sigma is the population standard deviation. It's gonna be like standard score is equal to raw score minus population mean all over population standard deviation. The area under the normal curve that lies within one standard deviation z is equal to -1 and z is equal to 1 is approximately 68.3%, while the area within z is equal to -2 and z is equal to 2 is approximately 95.4%, and within z is equal to -3 and z is equal to 3 approximately 99.7%. The 0 is the middle line and the negative and positive integer are symmetrical. The standard normal distribution has the following properties. Number 1, the total area under the standard normal curve is equal to 1. Number 2, the standard normal distribution is symmetrical about the mean. Population mean is equal to 0. Number 3, the area to the right and to the left of the mean, population mean is equal to 0, is 0.5. Number 4, the three measures of central tendency, which are the mean, the median, and the mode, are equal and are located at the axis of symmetry. Number 5, the tails of a standard normal curve are asymptomatic relative to the horizontal line. Number 6, the standard normal curve area may be divided into at least 3 standard scores, each to the left and to the right of the mean, before the left and the right tails appear to touch the horizontal line. Number 7, along the horizontal line, the distance from one integral standard score to the next integral standard score is equal to 1. Number 8, the probability that the standard random variable z will fall into an interval a to b is equal to the area shaded region under the standard normal curve between 2 points a and b. For example, a bank located in a business center wants to improve the processes in serving the customers during lunch break. They recorded the customers' time spent in minutes from entering the line until they finished their transaction. They found out that the customers spent an average time of 15.8 minutes with a standard deviation of 1.25 minutes. If the time is normally distributed, what is the probability that a customer chosen at random will consume more than 15 minutes to finish his transaction in the bank? Illustrate the problem in a normal curve. The probability z is greater than -0.64. Let us first specify the given. So the raw score is equal to 15, population mean is equal to 15.8, population standard deviation is equal to 1.25. In the problem presented, to find out the probability that a customer will spend more than 15 minutes to finish his transaction, we need to change 15 minutes to the standard score. Therefore, for us to get the standard score, we will be needing this formula. Z is equal to x minus mu all over lowercase sigma. You just have to substitute the values. So we have 15 minus 15.8 all over 1.25, and we will get the answer, which is negative 0.64. We now have the probability of z is greater than negative 0.64. To find the probability, we need to use the standard normal distribution or SND table. In the table, the standard normal value is written up the nearest hundreds. The z value up to the nearest tens is written vertically, and these are the numbers. In the first column, while the 100 digit is written in the first row, and these are the numbers. Since we got the answer negative 0.64, let us first look 0.6. And going to 0.04, and we will get its value, which intersects at 0.2389. To illustrate, this is the normal curve. The shaded region is from 0.64 going to the right side. Therefore, the probability z is greater than equal to 0.2389 plus 0.5 is 7389. Therefore, the probability that a bank's customer will finish his transaction in more than 15 minutes is 0.7389. To find the probability that a continuous normal random variable x lies in the interval from a to b, convert the value of the continuous random variable x to standardized random variable z, and use the standard normal distribution table. In here, we need to convert the value of normal random variable x into standardized random variable z with the use of standard normal distribution table. Let us have more illustrations. In a normal curve, identify the region being described by each of the following. Shade the region and find the area of the following. The probability 0 is less than z less than 1.50. Number 2, the probability negative 2.34 is less than z less than 1.50. Number 3, the probability z is less than 1.50. For number 1, the probability 0 is less than z less than 1.50. To find the shaded region, since the values of z are 0 and 1.50, the shaded area will start from 0 to 1.50. And to find the area, first we have to convert z values to standardized random variable with the use of standard normal distribution table. So 0 is still 0, 0, 0, 0, and 1.50 intersects at 0.4332. Second, we have to add 0.0000 and 0.4332. Therefore, and the answer is 0.4332. Therefore, the area of the shaded region is 0.4332. For number 2, the probability negative 2.34 is less than z less than 1.50. To find the shaded region, since the values of z are negative 2.34 and 1.50, the shaded area will start from negative 2.34 to 1.50. And to find the area, first we have to convert z values to standardized random variable with the use of standard normal distribution table. So negative 2.34 intersects at 0.4904 and 1.50 intersects at 0.4332. Second, we have to add 0.4904 and 0.4332, and the answer is 0.9236. Therefore, the area of the shaded region is 0.9236. For number 3, the probability z is less than 1.50. To find the shaded region, since there's only one value of z, which is 1.50, and use less than sign, Then shaded region is from 1.50 going to the left side of the curve or the given integers, and to find the area, first we have to convert z value to standardized random variable with the use of standard normal distribution table. So 1.50 intersects at 0.4332. 0.5 is added because the region of the negative integers are shaded. Second, we have to add 0.5 and 0.4332, and the answer is 0.9332. Therefore, the area of the shaded region is 0.9332. For your activity, this is your activity 1. Instruction: in a normal curve, identify the region being described by each of the following. Shade the region and find the area. The probability z is less than negative 2.34. Number 2, the probability 1.50 is less than z, less than 2.34. So next, from the previous illustrations, we determine the probabilities given the values of z. Let us try looking for the values of z when the probabilities are given. The random variable x is normally distributed with a mean of 42 and standard deviation of 5. Find the values of the random variable x and random variable z given the areas of the intervals under the standardized normal random variable, a normal curve rather. For number 1, between 0 and z is 0.3944. Number 2, between 0 and z is 0.2967. Number 3, to the left of z is 0.0207. For number 1, between 0 and z is 0.3944. We have here the given, which are population mean is equal to 42, population standard deviation is equal to 5, standard score is equal to 0.3944 is equal to 1.25. X is missing. The area from 0 to z is 0.3944, therefore z is equal to positive 1.25 or z is equal to negative 1.25. If z is equal to 1.25, we will be using the formula of standard score and then substitute the given values. Z is equal to 1.25, so 1.25 is equal to x. X variable is written because x doesn't have a value yet. Minus 42 all over 5 or the population standard deviation. And then the value of x or the answer is 48.25. However, if z is equal to 1.25, again, we will be using the formula of standard score and then substitute the given values, and then the value of x or the answer is 37.5. Therefore, the value of the random variable x is 48.25 or 35.75. For number 2, between 0 and z is 0.2967. We have here the given, which are population mean is equal to 42, population standard deviation is equal to 5, standard score is equal to 0.2967 is equal to 0.83, x is missing. The area from 0 to z is 0.2967, therefore z is equal to positive 0.83 or z is equal to negative 0.83. If z is equal to 0.83, we will be using the formula of standard score and then substitute the given values. Z is equal to 0.83, so 0.83 is equal to x. X variable is written because x doesn't have a value yet. Minus 42 all over 5, or the population standard deviation, and the value of x, or the answer, is 46.15. However, if z is equal to 0.83, again we will be using the formula of standard score and then substitute the given values, and then the value of x, or the answer, is 37.85. Therefore, the value of the random variable x is 46.15 or 37.85. For number 3, to the left, z is 0.0207. We have here the given, which are population mean is equal to 42, population standard deviation is equal to 5, standard score is equal to 0.0207 is equal to 2.04. X is missing. The area to the left of z is 0.0207. Since the area is less than 0.5, we can say that the value of z is negative. To get its value, find the area from 0 to z by subtracting 0.0207 from 0.5. The resulting area is 0.4793, which corresponds to 2.04 in the standard normal distribution table. Therefore, z is equal to negative 2.04. If z is equal to negative 2.04, we will be using the formula of standard score and then substitute the given values. Z is equal to negative 2.04, so 2.04 is equal to x. X variable is written because x doesn't have a value yet. Minus 42 all over 5, or the population standard deviation, and the value of x, or the answer, is 31.8. Therefore, the value of the random variable x is 31.8. For your activity 2, instruction, the random variable x is normally distributed with a mean of 42 and standard deviation of 5. Find the values of the random variable x and random variable z given the areas of the interval under the standardized normal curve. Number 1, to the right of z is 0.0485. Number 2, to the right of z is 0.9292. Number 3, to the left of z is 0.9861. A reminder, I gave you 2 activities and you can check this video for your reference in answering this. You can write your answers in a piece of paper and your answers should be posted in the folder of our channel. Thank you for watching and I hope you have learned something.